the sixth element, or let me just use zero based list. I want to remove the fifth element, so I will use 5. So when I say fifth, it means sixth element.
Yeah, got it.
Got it? So I can
Yeah.
do this, or this is one thing I can do, or I can even do this. Position plus equal to 5.
Yes.
Or I can even do this, auto equal to nums dot end. I can do minus 5. I can do this. Or I can do POS2 minus equal to 5. Or I can even do this. POS equal to POS plus 5. I have overloaded the operators for this also. The plus operator, remember? Erase. We did not check, we did not test erase, so I don't know if it's going to work. It should ideally. Something is, we have made some mistake. So position, invalid return type, T star for overloaded operator arrow. Cannot access the private member declared in iterator. Oh, okay. So I cannot access the iterator direct. I cannot access the m_ptr in erase. So no problem. I can make the list as a friend of iterator.
Yeah.
That's one thing I can do. Hang on.
This is not the list, I think, right? This is dynamic.
Oh, I'm sorry, dynamic array. Yeah, you're right. Just dynamic array. So friend class dynamic. Then just curious, when we implemented. Well, I could have calculated this in a different way, so there is no need to use friend. What I could have done is I could have used indices itself rather than modifying this entire code. Because now I can compute I can subtract one iterator from outside. So I could have done it anyway, but this is okay. This should work now. Just type P star for overloaded operator arrow. It has m_ptr. That's a member of the class. Anyway, we can call it like this, m_ptr. Oh, it has a pointer. Okay, it has a pointer. Yeah. It has a pointer inside. Yeah, that is another thing that you have to. Okay, I'll explain what this is. See why we had a problem here. I'll tell you. Let me explain it right away. Let me create a dynamic array of script string. Okay, Now, when I want to access the underlying elements, we saw that we can use d arrow c underscore str. Sorry, not d arrow. We first need to create the iterator d dot begin, and then p arrow c underscore str. Works fine. All right. But what if this string is a pointer? What if it is a pointer? Then this will not work, because this will resolve to pointer. So we will have to use star on this. Star p will return the value, and then we apply the arrow on it.
Yes.
Right? So it's the same problem here that we faced here. Position internally contains a pointer. It contains a pointer object. That's why either I do it like this, or I do star position arrow and then like this. This is what I have to do. So anything will work. So we'll just build this, and we'll see what happens here. So we are erasing the element. So found 12 at 0. Okay, that's fine. Then we erased the element at the 5th position. That was 16. 0, 1, 2, 3, 4, 5. 16 is gone. Can you see that? It is gone. So this works fine. Absolutely fine. There is nothing wrong with this. I want to do the same thing for the list. So let's copy this code. We did not implement a constructor that will fill the list with some numbers. I did not do that, unfortunately. So what do we do then? I don't want to waste time in implementing it. Can't do that. I can have a constructor that simply does this. It's not a big deal. So just quickly add it. So it will be list size underscore t count, and then element. All we have to do is just call push front element. That's it. And the other one, other constructor is count, and then list count, and it. Yeah, this works now. And let's comment all of this for a while, then build. Okay, we did not implement constness for the list. I'm not going to implement that. You already know what to do, how to do it. It builds. Let's run. Okay, so this is the dynamic. Sorry, this is not dynamic array. This is list. This is list and single list. Yeah, it works. So this is the output. Everything works. But then I want to find an element. Will it work with that? Let's find out. Does it work with that algorithm? Yes, it works. Will this code work? No, we build. It won't work. This doesn't work. because we did not implement the minus operator for the list. So let's go and implement it. So this is the iterator class. So who can tell me how to implement minus? The return type is going to be int, operator minus, const, iterator, other, const. What to do here? I'll refill my water bottle in the meantime. Tell me, how do we do that?
So we have this operator plus plus, right? So we can use that to move through the list. And until you get that other thing.
Yes, so we have to
just count
traverse.
how many times.
Yes, we have to traverse.
Yeah.
Is that a good idea to implement that here? What will be the time complexity of that operation?
Linear.
It will be linear, O of n. What about the time complexity of minus for the dynamic arrays iterator?
Constant.
Constant. So the iterator in list cannot implement this operator. So we cannot do this. This will not work. Cannot do this. We cannot add this operator. So we're out of luck here. So not found. Yeah, found 12 at, it's actually 1. Let's go further down. I want to erase the element at the 5th location. This doesn't compile. Why doesn't it compile? Because we have not implemented the plus operator. Can we implement plus operator for the iterator? What will you need to do to implement the plus operator?
Again, you can, but it's expensive. That's
Yes, it's expensive. So we cannot implement plus operator. So this also will not work. So what do you need to do then? The solution is you will have to manually increment position 5 times. So you might do something like this. Size t, I equal to 5, and then while I not equal to 0, you write position plus plus. That is the best you can do. And then you can erase at that position. We don't have, oh, we have erase after. Yeah. Then you can erase at that position. I think we implemented erase, right? Oh yeah, yeah. So we commented this out because we were using node, so we can easily change this to iterator. Iterator. Yeah, that would still work. Your pointer. Position arrow m underscore next. So position contains iterator contains m underscore p node.
so star position, right?
Yes, position is a pointer, so m underscore P node arrow m underscore p next. This is what we have to do. Even here. But then I'll have to make the list as a friend of the iterator. This. Does not have an overloaded. Got to update this. Easy. So it contains a node, and then you have to apply next on that, and then on that you have to apply next. So, but at least we're done with this now. This works, and then let's print the number that is erased. Okay, so we have messed up something. It has crashed. Find out why it has crashed. It went into a loop. Cannot open. Elevator. Process is still running. Just need to terminate it. Not visible. So sometimes what happens is, when Visual Studio is about to start to run an application, if you stop it from running it, it will stop. But the application will start and it will run in the background. So it doesn't show up here. It doesn't show up in the task manager. But if I just do, what is that? Button the command. Yeah, it is task list. Task list. So somewhere here we will have iterator. Try again. Okay, it's already terminated. Okay, no problem. So what have we done? We have erased the element after the fifth position, that is 0, 1, 2, 3, 4, 5. So 14 has been erased. Can you see that? It has been erased. So this works. But isn't this inconvenient? When you want to go to the specific position, you have to use a while loop. Can we write an algorithm that will do this for us? Yes, we can. We can write an algorithm that will do this for us. So let's write that algorithm, and I'll write that in the utils file. We will call this iterator. I will call this move to. It will accept an iterator by reference. Normally, iterators are passed by value, but this is a rare case where the iterator is passed by reference. A rare case because we have to modify. So we want to move this iterator to this position. Right? So this is what I'll do. or size p I equal to 0, I less than position plus plus I plus plus IT. That's it. That's what we have to do. And we can use that here. So this can be replaced with move to position 5. What do you think of this? Get the same output? 10 is removed. This is very important. We're actually discussing something else here, but it is in relation to iterators. Did you get it? Can I use move to even here? I can,
Yeah.
isn't it? I can replace this with move to position 5. That's it. And this will also work. So it works. So what is removed here is 16. Another copy of 16 is removed. Is that clear? Now, here comes the performance spot. When you use move to with a list, what it does is it traverses. It traverses. Plus plus IT means, let me keep a breakpoint here. I want to show you how important this is. Maybe I'll keep a breakpoint here. And let me increment in this loop so that I can break precisely on that line. So first it's let's check. Pay attention, it's very important. I'll press F5. So plus plus IT was called. If you look into the call stack, you will see it has been called from using list. It has been called from here, move to position. Okay, so what does it do? Let's go inside. Let's jump inside this function. It goes to the overloaded operator and then it moves. This is what it does. Okay, right? And then if I do the same thing for the dynamic array, what will move to position do? Move to position will traverse. But for iterator, could you not have, for iterator of dynamic array, could you not have done something like this?
Yeah.
So why don't we do this then? Why go through this long for loop? The problem is it will work for iterator of dynamic array, not for list. See? It will not work for list. So if I just comment this code for the list, it will work, but it will not work for list. So what to do? What we want to do is choose dynamically based on the iterator type.
To add another template parameter like that, whether it list or maybe something like that.
I think iterators can have a two variety, one like a sequential iterator and one like a random access iterator, right?
Yes.
And then you can type name will take care of the whole thing. Sequential access, random, something like that. I mean. Yeah, I mean, for example, suppose if you have assumption that our list is already sorted, right? The sorted array, for example, you can even implement a binary search if the iterator is like of that kind.
Okay. So here, as you rightly said, we see the algorithm, if it wants to be able to use the right thing, it should be able to know about the capabilities of the iterator.
Yeah.
And this is where we have the categories of iterators. Iterators have capabilities. So these capabilities have to be advertised to the algorithms so that they can be implemented more efficiently. Okay.
Yeah.
So it's like this. You have the skill of C++, you have the skill of Java, you have the skills of design patterns. So you would like to advertise these skills so that companies can hire you. Right? So for example, if we have a programmer or we have an associate programmer, associate engineer. So associate engineer will have the knowledge of basic C++. Okay, then we have team lead. Then we might have team lead. Obviously, team lead will know about basic C++ and may also know about advanced C++. May also know about STL. And then we might have architect. Architect will know about obviously advanced C++, STL, maybe design patterns. Will have some domain knowledge. So these are the capabilities of individual people. So anyone who is architect will already have the knowledge of team lead. So can act as a team lead, but won't. Or architect can act as a team lead or associate because architect has those skills. So these basically are the capabilities of the employees. In the same way, iterators also have the capabilities. So there are different kinds of the iterators can have different capabilities, and based on their capabilities, they are categorized. So the first type of iterator is input iterator. Input iterator means you can only read from it. You cannot write into it. Example of such iterator is the one that is provided by the iStream class. iStream class provides iStream iterator. You can only read from it. Then we have output iterator. Output iterators only allow you to write into them. Can you give me an example of who provides this iterator?
OStream.
Yes, OStream. Then we have forward iterator. Forward iterator can read and write, but it can only go in forward direction. Input iterator and output iterators can only go in forward direction. Forward iterator can go in forward direction, but can read and write. Then we have bidirectional iterator. Bidirectional iterator can both read and write and go in forward and backward direction. And finally, we have random access iterator. So just like architect has the capabilities of all the other employees, in the same way, the random access has the capabilities of bidirectional iterator. The bidirectional iterator has capabilities of forward iterator. The forward iterator has capabilities of these iterators. So basically, what I mean here is that a random access iterator can be used wherever bidirectional iterator is used or wherever forward iterator is used. Who provides forward iterator? We already implemented forward iterator. The list provides forward iterator because it can only move forward, it cannot go backward. Who provides bidirectional iterator? Can you tell me?
Dynamic
Vector.
array.
Vector, like in a vector time. And
Arrays can also provide, right? No.
You're right, but it is not completely right. Two-way linked list. Two-way linked list provide bidirectional iterators.
Okay.
You can go from head to tail or tail to head. Who provides random access iterator? Arrays. Arrays provide random access iterator. You can go to any location in constant time. Now, when you said dynamic array provides bidirectional iterator, you're not right, but you're not also wrong. Because the dynamic array provides random access iterator. Random access iterator can act as a bidirectional iterator also. You understand? Isn't it?
Yeah.
Yes.
Random access iterator can also act as forward iterator. Isn't it acting as a forward iterator here? When the iterator is of the dynamic array. So the minimum, so basically, these are just capabilities and the iterators should advertise them. How do we advertise them? That is the question. We can advertise them by using type traits or iterator traits. What are iterator traits? They are simply some things that tell you about the qualities, attributes of the iterator or traits of the iterator. So how do we create the trait? We will create a type def. So here I will use iterator category and I will initialize it to a trait. Let's use built-in traits. Let's not waste time in creating our own traits. So the trait that I will use for this is forward iterator tag. This is an empty class. It is an empty class, bidirectional iterator tag, random access iterator tag. These are empty classes. They only act as placeholders. That's all. So I have forward iterator tag in iterator. In dynamic array iterator, I will use random access iterator tag. Now I can utilize these in my algorithm. Okay, so I can get the tag from the iterator. So IT scope iterator category. I will get it like this. I can use iterator directly here. So here I can get the category. Before I show you, let me first show you the information of the tag.
So Umar, can you show us how you declared? Is that using operator?
This tags.
This syntax, can you just?
This is the new aliasing syntax. I talked about it on the first day.
I agree, but here, is it just a member?
It
that
is
we got?
a type. It is a type def.
It is a name kind of different name for
Yes.
that thing.
Yes, I am just creating another name for forward iterator tag. I could have also done it like this. Type def std forward iterator tag is iterator category. I could have even done it like this. So it is a member of the class, a name. It is not a variable. It is just another name. That's all. Got it? Yep. So, yeah.
No, here you did a type def, but you did not add any public member to that class, right?
Which class?
Iterator class.
I added this type def. There is no need to add any member.
Okay, so you're saying this type definition is only scope to your class, iterator class.
Yes.
It's not publicly available, and there you will check whether that definition is available to you. If it's that available, you will do something about it. I see.
Yes.
I see. Now I got the logic.
Yes. So let's first see what is printed for list and dynamic array. So for list, it is forward iterator tag. For dynamic array, it's random access iterator tag. Now, the thing is, how do we compare it? We can compare, it's not something that you can compare like this. Iterator category equal to std. If it is forward iterator tag, you cannot compare like this because these are types. You need to compare types, not values. So for this, you cannot use equal to operator. You have to use
Type ID.
Uh, well, that is not going to work. We could use type ID, but it is not going to work. Tell you the reason why. And you'll also learn about C++17 feature. So I can try comparing the type ID, but in our case, it is not going to work. You were right in saying we can use type ID, but it will not work. I'll tell you the reason why it doesn't work. So if it is forward iterator this, and then we'll write else. If it is random access iterator tag, then I will use this. For the time being, I will just print a message here using linear jump. And here, using direct jump. Let's see. This works using linear jump and using direct jump. Now, why I said it won't work? The problem is, if you try to compile it now, this move to algorithm will be compiled for two iterator types. There will be two instantiations, one for the iterator of dynamic array, other for the iterator of list. When this function is compiled for list, what will happen here?
Oh, so you are saying this if and else, they are dynamic entities. That's
They're
what you're
dynamic
saying.
entities. Yes,
They are not statically chosen. Yeah.
Fortunately, we cannot compute them at static at compile time using type ID. We need to use something else.
Okay.
And I need to search in the standard library for that because I have forgotten that. Hang on. Found it. Yeah. So I have to use type traits here. I have to basically use the metaprogramming library. So here I'm comparing the type information of two types, which is done at runtime. What I want to do is compare the information at compile time. So I can write the same thing as, using this trait called is underscore same. And the argument that you have to give here is the types. So the types are, I will write is underscore same as this. Is it same as this? Is same, and then I have to apply the value on this. If these are same, value will be true. Otherwise, it will be false. Same thing over here. So this will also work in the same way. So if I just compile this, include the type traits library. The header for this type traits. Okay. Okay, I'll tell you what the problem is. Tell you what the problem. Tell you what the problem. Let's go here. What I might do here is I might create the iterator manually. Maybe if I let me show template type name P, and I invoke this F like this. So I'll create dynamic array of integers, and then I'll call F like this. Fine, nothing wrong with this. This will build. There's nothing wrong. And then I want to create an iterator. I can always do auto it equal to c dot begin. But for some reason, I don't want to use auto. Maybe I'm not using C++11. So I will have to write something like this: T scope iterator it. Okay. The problem is the way this code, the template code is compiled, the compiler may not be able to figure out what iterator is. Is it a class or a member or a variable or a static variable of the T class? So it might not compile. It might give a compile time error. So what does it say? It says syntax error, unexpected token, identifier following expression. So what we need to tell the compiler is that this iterator is a name, it's a type that is dependent on the type of P. Do you understand? It is dependent on the type of T. Basically, it means, see, if I write F3, obviously this is wrong, this is incorrect. So how will the compiler know that iterator is a nested member of P, even though the templates are compiled in two phases? Okay, in the first phase, the compiler will check for syntax errors. In the second phase, it will actually instantiate, it will replace or substitute T with the actual type. But by that time, the compiler already complains about this iterator. So we need to tell the compiler that iterator is a nested type, or it is dependent. The type of iterator is dependent on T. That is why we have to use something else. And that's why you see the tool that I use, it says dependent type requires using type name keyword. So I have to use type name here, which is applied to iterator. This tells the compiler iterator is actually a type, not a static variable, which is declared inside T. Run now. This is the reason why they added type name. Otherwise, we could have used class. In old C++ books, you will see class. So type name was added for this purpose. Is that clear? So this is why it is complaining here. It is not. It doesn't know about iterator category. All we have to do is just use type name here. Builds, yep, and works. But problem, this will not compile. What to do? There are many things we can do here. So let's cut the long story short and directly use C++17 feature. If you're interested in knowing the other ways, we can discuss it offline. But for now, what I'll do here is, see, the problem here is, even though when this iterator is of type list, compiler will still, even though it will never use at runtime, it will never go to this branch because this will evaluate to false for list iterator. But compiler will still compile this code. And during compilation, it realizes plus equal to does not exist in list iterator. Is that clear?
Yeah.
Yes.
What if now there is a way? There is a way in C++17. So these conditions, basically, these conditions are evaluated at runtime. If we could evaluate these at compile time, then we will not get the error. So I will use C++17 feature called compile time if. That evaluates the if condition at compile time. So all I have to do is use const expert here. What does this do? The compiler evaluates this at compile time. How can it evaluate this at compile time? Because the iterator category is already there in the iterator at compile time, and at compile time, the compiler instantiates move to based on the iterator type, and it can figure out the iterator category at compile time. So hear me out. When move to is invoked for the dynamic array iterator, this branch at compile time is removed. It is removed, completely removed. So only this branch exists. On the other hand, when move to is invoked on the list iterator, this branch is completely removed at compile time. That is why this will not give any compilation error, and it works. Did you understand?
Yeah.
And I will prove it to you. So we will invoke move to, I'll give a breakpoint here on move to of dynamic array and move to of list. So first it will call move to for list. It will call move to for list. Okay. Let's open the disassembly window. This is the disassembly window, and let's go down. It has reached here. Can you see? It did not go to the if. It did not go to if. It has directly reached here. Where has it reached? It has reached to using linear jump. Can you see that? See out statement. Then it sees it. You see the for loop. See the for loop. C plus plus it. What should appear after plus plus it? The other else if condition. Show me where it is. Where is the code for this condition? It's not there. You see that? It is not there. So please remember this. Remember this code. Let me take a screenshot. Let us come out of the function. Let us come out of the function and call move to on the dynamic array. Let's go inside move to. Where is the code? Where is the if condition for linear jump? It's no longer there. Instead, you only have direct jump. Compare it with the earlier implementation, the earlier generated code. You get the point?
Yeah. So I think
So there
in
are
C, we used to have this hash define, if def, and all those
yes.
macros are there, right? So this is a bit better readable, and maybe
This is far better because this is managed by the compiler. Hash define is managed by preprocessor, and compiler doesn't know anything about it.
yeah.
This is one way of doing it. There is another way also. There is one more way, but I don't want to get into that. And that is called tag dispatching. So did you understand the reason why we need to have iterator categories?
Yeah.
So now I can use move to without worrying about how it will perform for random iterators and forward iterators. In the same way, we want to print the element that was found, which we could not do for the list. Remember? Because we cannot implement minus operator. Let us implement a function that will compute the difference between two iterators, how far one iterator is from the other. So I'm going to create one more function. I'll call this distance. Iterator first, iterator last. And I'll do the same thing. I want to compute the distance between two iterators. So this is what I'll do. Int distance, and then first not equal to last. First not equal to last, and distance plus plus and plus plus first. Right? And then here we will return distance. This is when we have forward iterator. When we have the random access iterator, I can directly do distance equal to last minus first. Right? And I can use this distance here. I can use it here. I'll replace this with distance nums.begin it. I'll do the same thing here. Good. Works for list found 16, which is a divisible of 4 at 0. Found 16, same thing for dynamic array. Why is it generating same numbers? Because we are using srand. Yeah, it doesn't matter. We are using srand at both the places. Is that so? No. Sorry. It's here. This is dynamic array output. This is list. So found 0 at 5. Yeah, this is divisible by 4. The first number divisible by 4. And here found 16 at 4. Yeah, here you go. Did you understand? So how were we able to do this? It was because of metaprogramming, template metaprogramming. We are performing operations at compile time. This is a compile time condition, not runtime condition. But it will also work at runtime if required. Is this clear? Good. So did you understand the purpose of move to and distance? Why we need them? And with this, you have understood why we need iterator categories. What is the purpose of iterator categories?
So basically, the algorithms have category-specific implementation. That's essentially the fundamental
Yes.
takeaway.
Yes. The categories are not random. You know, there are only 5 categories. There can never be more.
Yeah, I mean, they are very general in nature, right? So most of our requirements are captured by them.
Yes. Yes.
Umar, in line 71, we do not have initialized distance, but we are doing a
We have. When you use curly braces like this, the distance is automatically initialized to the default value of int, the initial value of int, which is 0.
Oh, okay.
This is called value initialization in C++.
Okay.
There are different types of initialization in C++. Would you like to see them?
Yeah, sure.
Okay, I'll show you. There's a video that shows, it's a 30-second clip that shows the initialization in C++.
Okay.
Okay. So by the way, do other C++ programmers know the different types of initialization in C++? What are the different ways? What are the different types of initialization? Do you know how many types of initializations we have? You have any idea?
I mean, there are
If
like
you don't,
a couple of stuff that I came to know well in this training. much more
okay.
of them.
How about other C++ programmers? How many initializations? So we have, I'll tell you a few ones, value initialization. And then I'll show you that video. So this is called value initialization. Value initialization. Then we have direct initialization. This is called direct initialization. Then we have copy initialization. Then we have static initialization. And then we have list initialization. And we have a few more. Let me open that video. Hang on.
Looks like an array, but why do we call it a list?
This is the list in it. This is the list of elements. This is still an array, but this is the list that we refer to, list initialization. Okay. Or braced init list. Yeah. Here. So there is no audio. It's just video. So watch this. These are different kinds of initializations in C++. So this is one of the pain points in C++, the initialization. It's just bonkers. There are around 20 ways you can initialize in C++.
Mm.
So this is initialized to 0. So I hope you got a good idea about iterators now. What are iterators? What are iterator categories? Why do we need iterator traits? So if you create your own iterator class, you will have to specify these traits. And this is just one of the several traits. There are other traits also. Okay. And those traits may be used by different parts of the standard library. That is why if you create your own iterator, the standard library provides a helper class, which allows you to easily add the traits to your iterator class. That class is std iterator, the one that you saw earlier. Okay, let me show you that iterator class. This is the iterator class that you saw. What does it contain? Nothing. It only contains the traits. It helps you to implement traits in your class. What does it say? Base type for iterator classes. It only contains traits and nothing else. So it is a facade which simplifies the implementation for you. Fortunately, you see this? From C++ 17 onwards, it is deprecated. You see, there's a warning. It is deprecated now, so we don't use it anymore. Why? Because the argument is that it is very easy to add these to your class. Very easy. So let me add these to my class, to at least one of the iterators. So we already have the category. The value type is, what is the type of value that it is going to have? That is the element type, that is T. Then the difference type. The difference type represents simply the subtraction between two iterators. It is an int type. Then pointer. Pointer is going to be T star. Then reference, that is going to be T ampersand. That's it. That's what the traits are all about. So I can then use this, use this in many places. For example, instead of T ampersand, I can use reference. Instead of T star, I can use pointer. So these are required. The type traits are required. We will see some more type traits later. We'll see one more use case where they are important. Understood? Yeah? Any
Yeah.
questions?
No. So the how that is same type is implemented, that would be interesting. So because so it will simply check whether this type def they belong to the same type def or something like that, no?
I'll show you. I'll show you how they are implemented. I'll show you. It is all compile time. And you'll be surprised to know that the implementation is very, very simple. If you know the basics of templates. You remember when I implemented I showed you that we can now traverse the dynamic array in reverse. I wrote that code. Remember, we wrote begin -1, end -1. Remember? So
Yeah.
sometimes we do want to traverse a container in the reverse order. And it's not something that is rare. It might be required. You want to go from the reverse order. Okay. So for that purpose, instead of letting the client traverse from the end to beginning, and again, that is error prone because a novice might do something like this. A novice might do something like this. And for example, begin equal to nums dot end. And then while b is not equal to nums dot begin. This is completely wrong. Why? Because b will not point to end. B will point to the position beyond the end. And this will cause a problem. So that is why we might want to provide a helper class that will help us traverse a container in reverse order. So I will add a new class. Maybe I can add that in utils, and I will call this reverse iterator. And this will contain same methods that this has. The common ones, I need the common ones. Copy. And it will have iterator as a member, the template, iterator type. Creating a mess. So this is the reverse iterator. And the implementation of plus plus will be this. You understand? This will be reverse iterator. The implementation of this decrement will be plus plus iterate. I'll not implement the others. You can implement them on your own. And then the comparison here is between this. So this is iterator.
I think it would be T and that's a
T
type.
star iterator. Just a second.
And the return type should also what element type. What is
Right. So this would be reference should this.
Mhm.
That's going to be a problem. And even this is going to be a problem. I don't know what is the return type of star ITR. Unfortunately, I don't know what that is. This will be like this. This is going to be a problem, see? So for the time being, let me use auto here. Okay, let me use auto here for the time being, because I just want to make this work first. Now, how can I use this? I can construct a reverse iterator, dynamic array here. So uh, just initialize this with 1, 2, 3. And if I want to traverse in reverse, I will construct a reverse iterator like this. Reverse iterator. The iterator type is going to be dynamic array int iterator itr equal to a dot end. Then while itr is not equal to, I have to construct the n minus 1. Just a moment. Then well, this is not equal to create last also. This will be begin -1. So it prints 3, 2, 1. But do you know how complicated this is to, initialize like this? It's very complicated to use. That is why in the dynamic array, in the container itself, I will provide functions called, there will be words iterator, and then iterator type is going to be iterator. I'll call this r_begin. R_begin will create instance of the reverse iterator, like this, reverse iterator, and then call end -1. In the same way, I will have r end. Make sense?
Yeah.
Then here, I don't need to do this. I can just say a.r_begin and a.r_end. This is, okay, something is wrong.
R end, line 89.
R_end.
Yes, r_end, yeah. This works. If this becomes too much to do, so we can use auto here. There's no need to use this entire thing. So we can use auto. What if I try to use it with a list? Let's use it with a list. So I create a list, and list doesn't have r_begin and r_end. If I try to manually, if I try to manually do that, for example, I try to create a list of 5, and then I say maybe begin, and I say end. For example, I do something like this. It's not going to compile.
Do you mean R begin R end? The
There is
list
no
has a begin
r_begin
and end, right?
Yeah, I have deliberately used begin and end. I just or
I think we implemented it for list.
no, we did not implement it for list. It's not possible to implement it for list. It's impossible to implement it for list. Hang on. So let me change this to list. This is 5. And even if I use begin and end and use list here, yeah, this should not compile. This will not compile. Why this will not compile is because the iterator that the reverse iterator can work with must be a bidirectional iterator. See, you cannot go in reverse in a forward list. Can you do that? No, because if you cannot, there is no backward pointer.
Yeah.
So it will not work. That is why we won't have r_begin and r_end in the list. So there is no point in using begin and end. Okay, so the reverse iterator, what does it do is it changes the interface of the iterator. It changes the meaning of the iterator. Yeah, so this is another iterator type. See the advantage of using iterators. I can create new algorithms of traversal without modifying the container class. For example, I create a binary tree. I can traverse the tree in order, post order. I can traverse in different ways. This is the advantage of keeping the algorithm outside the container. Okay. Questions? This is how we can use reverse iterators. So I think we're done with iterators. I don't think there's anything else that we have to deal with. Yeah, this R begin and R end that we have used, there will be other variations also. RC begin and RC end. You know, constant reverse iterator and constant reverse iterator. So there'll be those variations as well. I'm not going to implement that. I think we're done with iterators for now. There is another important thing that we have to, that is the last important thing about iterators, and that actually depends on the container type. And I'm going to look at the implementation of erase here, erase and insert. Insert will not work, but because we did not implement it, so erase, I have to look at erase. Let us return the iterator prompt. This will be so here I will return end, and here I will return the new end. It's fine. And here I will return the position of the next the next iterator. So this is going to be auto next equal to position plus 1. And then I'll return give me a moment, I need to check something, and then I'll tell you what to do next. I want to ensure that this works. Really, we cannot do that without implementation of the iterator. Right in a different way. So any questions so far? Did you understand iterators and why we added these functions, distance and the move to function, why we did that? So I hope you got a fair idea of containers now. You got a fair idea of the iterators. There is another important concept that I have to explain. Let me explain that in a different project. Need the same files there. So for this, I will need the implementation of insert. Unfortunately, it's not complete. It's missing something, but still we will be able to see something here. I've created a dynamic array of 10 and there are random numbers inside it. So let's see what those numbers are. I'm not going to see the random number generator because I want the same numbers every time. So that way we will be able to keep track of things. And let's have lesser number of elements, maybe 5. We have 1, 7, 14, 0, and 9. We'll always get the same numbers because the generator is not seeded. And let's also try this. Suppose I get the iterator to begin. I get the iterator to begin. And then I want this iterator later. I have to, the element that it points to, I want that element later. Maybe that element is maybe the second element, okay, or the third element. And then later on, I will display this element like this. Display it here. That is 14. That's perfect. This is what we want. And then later on, I perform some operation on the dynamic array. Maybe I emplace back a few more elements, maybe 100, and then 200, and so on and so forth. That's what I'm going to do. And then later on, I use the iterator. I print the element again. What happened? Lost. Why has it lost? Why is it lost? Why don't we get the value?
So because the object changed or something?
The object is same. It's the same object.
Somehow iterator changed, right? So
This is the same iterator, not different.
okay, the locations I think because we might have exceeded the capacity. No, not capacity also. Right?
Change happening in place back.
Okay, so I think this dynamic array we can resize, right? If we add some more element than capacity. So I think that reallocation has taken place. That's why I think we are
Yes, exactly. So reallocation took place. When you emplace back, see this iterator is going to point to the location of that element and it will store that address. But when you call emplace back, the array is moved from that address into a new address. But your iterator will continue pointing to that location, which is now invalid. Okay. Now, normally we don't have to do anything for this because usually Visual Studio will warn you about these problems when you use the standard iterators. But what is happening here is to the iterate, first of all, dynamic array internally allocates memory. And we are referring to that memory and we are accessing that memory. But in this case, we are accessing memory that has already been freed. So this is same case as so how do we detect these problems? Usually, Visual Studio will not detect these problems, and you may not even get any kind of errors here. See? Okay, it has crashed. Doing access violation. Normally it shouldn't, but it's just I don't know, it shouldn't. Maybe something has been added, but it usually doesn't. Oh, it's because of this. This is a recent change in Visual Studio. But let me show you another way through which we can detect this problem. So I'm trying to modify it, but what if I try to read from it? I try to read from it. It's crashing again, but there is another way through which we can figure this out. It doesn't tell us anything, it's not very helpful. What we can do is we can use something called address sanitizer or ASAN. Visual Studio has built-in support for ASAN. So to turn it on, this is what we will do. We will go to project properties. There are three things you have to do. Expand CC++ general and choose enable address sanitizer. This is the first thing you will do. The second thing is you have to choose this program database. You have to choose only program database, not for edit and continue. This is the second thing you have to do. Okay. Third thing is under code generation, the basic runtime checks should be default. That is the third thing. And then one more check in linker under here. This should be no incremental linking. Let me verify this. There's a couple of these steps that we have to follow. Yeah, we have to turn off incremental linking. That's it. And then When I run my program, if you look in the output window, yeah, this is what I wanted to show you. This is the output you get. This is because of address sanitizer, and this is what it says: access violation on unknown address. So it says the signal is caused by a read memory access. So you're trying to read from memory that doesn't belong to you. Okay, and it even shows the stack trace. So let's try using it for this dynamic array. Maybe it might catch this error. Yeah, see, it catches this error. What does it say? It says heap use after free. You're trying to use heap which has been freed. Where? It is happening in main.cpp line number 41. That is here. Okay, and it says this address is located 8 bytes instead of 20 byte region. And this memory was already deleted, which was allocated in reserve. And then it gives some more information. It shows you this thing, and there is a way to interpret this. I cannot explain that here. But it tells you that something is, so you're trying to see if I turn this address sanitizer off, you'll not get any error. It simply displayed some value. So as you rightly said, we are trying to access the memory. The iterator is pointing to memory that no longer is used by dynamic array because the array has been relocated somewhere else. The bottom line is that you have to understand whenever you use iterator with dynamic array, the iterator may become invalidated when you perform some operations on the container. What are those operations that cause invalidations? The operations are emplace back or push back, insert,
Deletion.
or erase. Erase. These will cause the iterators to become invalid. Not only iterators, even pointers to elements or references to elements will become invalid. Okay, for example, here, instead of creating an iterator, I create a reference to the first element. I create a reference to the first element, and I print that here. And then I print it again here. Let's turn address sanitizer off. See, the ref is 1 here, and here it is invalid. Understood? Yeah. So references, iterators, and pointers will get invalidated in a dynamic array. What about list? Let's try the same thing in a list. We don't have emplace back, and we don't have this +2. We can always use move to, but that's unnecessary. And here I will use push prompt. What do you think will happen here in case of list?
While pushing, it might not happen, but while, let's say, you delete or something, it might happen.
See, when you are pushing at the front, there is no reallocation. When you have a list like this, so you created an iterator or pointer or reference to this.
Yes.
If you push front, a new node will be added here. Will that cause a change to this node? No, it is still there.
Yeah, with the push
So
operation, not there. But if we kind of, let's say, remove something like pop or what to say, like that.
Hang on, we'll see that. Hang on. We'll see that. So with insertion, the iterators, references, and pointers will not become invalid. They will not become invalid in the list. Let's first see this. See? Still there. The ref is still there. Now, what about erasure? Instead of push front, let me erase something. Now, there are two things here. If you erase the element that the iterator is pointing at, then obviously iterator will become invalid. But if you erase at any other position, the iterator will not become invalid. Okay, for example, I will call, instead of push front, let me say nums dot erase after nums dot begin. So that means the second element, my iterator is pointing to first, but I really delete the second element. Is that going to make any difference? It's not going to make any difference. See, the elements are still there. Did you understand? So in a list, insertion and erasure does not invalidate iterators, references, or pointers unless the element to which the iterator is pointing to, that element is deleted, that node is deleted. Otherwise, it will never become invalid. This is very, very important concept. We'll revisit this later again. Got it? Clear? So we have seen invalidation for array and list. It's actually more complex than this because there are cases, many cases for arrays. For example, this is my array, dynamic array, and these are the elements. And this is the free space. Suppose I have the iterator pointing to 3. Will this iterator become invalid if I remove 5? No, it will not become invalid. Will this iterator become invalid if I push one more element here? No, it will not become invalid. But there's a chance. If this reallocates, then this iterator will become invalid. So you got to be careful. So it's better to always initialize iterators before using them. Then look at one more case. Suppose I remove 5. This iterator will not become invalid. But what if I remove 2? This iterator will become invalid because now the elements will be shifted. So you'll have 1, 3, 4. And iterator will now point to 4. It is no longer pointing to 3. So these are the different cases. So in general, iterators in dynamic array will become invalid. But in list, they will not become invalid unless the iterator is pointing to the node that has been deleted. Is this clear? And we'll also see it for other data structures. Any questions? I think we'll take a break of 15 minutes and then we will discuss something more interesting. So you remember this reverse iterator that we implemented, and we were not able to figure out the return type of these operators. So what are we going to do here? If you remember, we added the iterator traits. So we added these iterator traits. Remember, I told you they will be used at other places also. So we use the iterator traits over here to figure out what is the category of the iterator. That's fine. Just like we use the iterator category, in the same way, there is another trait called value type. Then there is pointer and reference. So all we have to do is, instead of struggling to figure out what this should return, we can use iterator type reference. And here we can use iterator type pointer. Remember, these are the traits that we added here. Okay, that's why these traits are required. And here we might have to use type name. Let's see if this will work. Without type name, I think we'll have to give type name. Yeah, so we have to give type name here. Yeah, I just remembered this. I thought you should know about it. This finishes iterators. We're done with iterators. So do you have any questions? Anything at all before we move on? We have implemented a lot of stuff. We have implemented almost half of what STL provides. Not half, but some part of it. Now we will move on to the standard template library. Now is the time. So what is the standard template library? It is the library that provides common utilities or utilities that are very frequently required in many applications. And these utilities come in the form of containers. That is, containers are classes that can hold objects of other classes. So they can manage a collection of objects. And the containers provide a uniform interface. What are those containers? The different containers, there are a lot of containers provided. So the first thing we have is containers. And there are different types. The types are sequence containers. What are sequence containers? These containers store elements in a sequence, one after the other, and there is no ordering. The different sequence containers are array. This represents a static array. Then vector. This is just like our dynamic array. Then forward list. This is just like our list. And then finally, we have the list. This is a two-way linked list. This is static array. Static array. This is dynamic array. This is a one-way linked list or a singly linked list. And this is doubly linked list. But this is one category of containers. The other category is associative containers. And there are the associative containers provided are set, multiset, map, multimap. And then I'm just going to circle some of these containers. Oh, there is one more, I forgot. There is one more here, and that is the deck. This is the double-ended queue. And then we have unordered containers. Unordered containers. We have unordered set and multi-version of unordered set and unordered map and unordered multi-version of unordered map. So we'll see what these are. But these ones, that is the array, the forward list, then unordered containers, all these have been added in C++ 11. The rest were present since C++ 98. Okay. This is about containers. Then what else does it have? It also contains algorithms. What are algorithms? These are generic functions that operate on different containers. And there are different kinds of algorithms. We have non-modifying, modifying, mutating, then removing algorithms. Then we have sorting algorithms. Then we have numeric algorithms. So there are around 100 algorithms. And these can operate on the containers. But how do they operate on the containers? They operate on the containers through iterators. So iterators is the glue between the algorithms and containers. And as I said, there are different kinds of iterators. We have random access iterators. We have bidirectional. Then we have forward. Then we have output. And then in. So these algorithms operate on different containers through iterators, and the algorithms can be customized. Okay. There is one more thing from C++ 17. The parallel versions of the algorithms were added. They're called parallel algorithms. So many of these existing algorithms have been parallelized. That means they will internally use multiple threads automatically. Some new algorithms were added. Now, as I said, these algorithms can be customized. They can be customized using function objects. There are different kinds of function objects. We have relational function objects, relational, comparison, then logical, then we have a numeric. What do these function objects do? They provide wrappers around common operators, such as for relational function objects, they provide wrappers over less than, greater than. Comparison, this. Then logical, this. Then numeric, plus, minus, multiply, and so on and so forth. These are the main components of STL. Now, when we say STL, we typically mean containers and algorithms and iterators. But if we talk about the C++ standard library, the entire library, that will also contain support for input-output, that is streams, that will contain support for regular expressions, that will contain support for concurrency, synchronization, a random number generator library. So that is different. So what we are discussing is STL, which is specific to containers. That is what we will focus on. Okay. So let's see what these containers are. What are the sequence containers? So we'll start with the array class and why it is so useful. The array class is a very thin wrapper around a static array. Obviously, it is non-growable. You cannot grow it. To use this array, you have to include the array header file. And why would you use it? Suppose you write a function called print, and this you want to print an array. But we have already seen that you cannot pass an array into a function. What you pass is a pointer. So I might pass it like this. Then this is the typical C style implementation. Then here, I create an array like this. And then, the same problem, we have to pass the size. Instead of this, why not use the standard array? How do you construct a standard array? You construct a standard array like this. It's a class template. What you need to specify is the type and the size of the array. And by default, the default constructor will create an array which is uninitialized, contains nothing. But you can initialize it if you want to. So I can initialize it with these values. Then how do you access these values? The subscript operator is already overloaded for this object, for this class. So you can use the subscript operator if you want. The other way to access the elements is through iterators. So you can use the range-based formula. That will also work. Right? Then it provides a method called size. You can get the size of the array. Then it provides a method called data. That gives you access to the underlying static array, which you can use with C if required. So I can write the same print function for array like this. The information of the size of the array is embedded into the type itself. It doesn't matter if you pass it by value. You can pass it by value because there is no copy. And then you can just do this. Or if you want to use this style, this will also work. So this will be arr.size, and this will be arr. Can pass this array like this.
Here
No need to pass the size.
Here in line till will we
Right.
still need that template inputs for the array or not required?
Yes, we need to. You need to specify precisely the type and the size. You have to, because it's a static array.
Umar, what were we expecting when we do a dot data? The full array would print out.
Pointer would. No. It will not print. It will give pointer to the. It will give address of the. It will give the base address of the array, and that is sometimes useful. That is sometimes useful. So suppose why is that useful? Suppose I have a legacy function like this, and I would like to use the array with this function. Then how can I use it? I can still use std array with in C style. So I'll write print a dot data and then a dot size. Okay, is useful. Yeah. So there is no reason to use static array. That is built-in static array. You can always use std array. What is the memory footprint of std array? It is no worse than the built-in array. No worse than the built-in array. What is the performance? Exactly same. Because if you look at the methods, they are inlined. See the array class. What does it do in, for example, so these are the iterators. What does it do in size? It returns size. What is this size? This size is nothing but the template parameter. It is not even stored as a member. So the memory footprint doesn't increase. And then what is the subscript operator? Plus the subscript operator that simply returns the element at a specific position. There is another method called at. The difference between at and subscript operator is there's only one difference. Both provide access to an element based on its index. The only thing that at does differently is that if the position is wrong, it throws an exception. That's it. Subscript operator does not throw an exception. I can show you that. So I'm trying to access maybe A of 10. This will not give any error. It will not throw any exception. It gives this debug assertion failed, but this is an assertion, and asserts work only in debug builds, not in release builds. So in release build, you will not get any error. No error. Basically, the result is undefined. We don't know what will happen. See, it worked. But if you want correctness, then you can use at, which is in many STL containers. This will throw an exception. Do you understand? The array class?
Yeah.
So it's very simple to use, very easy to use. Any questions?
So Omar, one question. So you said they overloaded this access operator, the two square brackets,
Hmm.
in the STD array, and they also implemented this at.
Yeah.
So again, was there a specific reason why one is better than it? Like one throws exception, one doesn't throw exception. So is the reason again the same? One was implemented way before and one was implemented after. Or
No.
then why couldn't they add this exception in while overloading this operator?
What is the primary reason C++ is still being used? When it is so complex to learn, then there are other easier languages to use.
Faster than other
It's
languages.
fast. It is fast. It's because of its performance. The philosophy behind C++ is that you should not have to pay for something that you do not use, and you should not get any surprises. So there should be, so your code should directly execute on the CPU without having anything in between. Unlike Java and C# where they have this just-in-time compilation, then there's the code gets converted to this bytecode or intermediate code. We don't have anything like that in C++. So when you use exception handling, there is a very small amount of overhead in your program. Why? Because the compiler has to add unwind handlers, unwinding, support for unwinding. Stack unwinding. Concept of stack unwinding. So it has to add support for that. So that is a small overhead.
Okay.
Got it? You can avoid that overhead by not using exception handling. So that is why you are given a chance. The programmer, it is up to the programmer whether they want performance or correctness. If you are sure that whatever indices you are going to pass in A, if you are sure that they're always going to be right, why to use ACT?
Makes sense.
If you see the implementation of ACT, it is slower as compared to this. You can ignore this debug code. This debug code, you can ignore this. And it says it's inactive. Why? Because I'm compiling in release build. So when you use ACT, there is always a check. But in subscript operator, there is no check. So which is faster? Obviously, this is faster.
Subscript operator.
In the if I go in debug, then this will become active. Obviously, because now we are in debug build. But the thing here is there are many things in C++, many library components where you can decide what kind of error checking you want to use. For example, in IO streams, in file streams, when you work with files, if you try to open a file and it cannot be opened, what will happen? What happens? There is no exception. Instead, it sets a stream state, which you can query using if condition. But you can even turn on exception handling. So when the file open fails, it can throw an exception.
Okay.
So they have given control to the programmer.
Thanks.
Any questions on array?
Slight, I mean, slight divergent question maybe, if it's okay. But since you're talking about the exceptions, I think that's very relevant to the context. Okay. So, I mean, historically, there has been two communities. One says pass the error codes, other says throw the exceptions. And what's the guidance of standard to us now with C++?
Well, the thing is, if you can, if some part of your program have exceptional behavior where you need to handle something, can you handle that without exception handling? If you can, then don't use exception.
I see.
Okay, but if you cannot use, if you cannot do without exception handling, then use it. What is the example? The best example is the subscript operator itself. How would you indicate to the caller that this position is incorrect? How will you indicate that here? Through a return value. It is impossible.
Yeah.
It is downright impossible. Or forget about subscript operator. What about at? See, at returns a reference. What value will you return to indicate failure? It's impossible.
Right. Yeah.
So the only way to do that, the only way to indicate is through exception. So you have to throw an exception. So this will internally throw an exception. Understood? Okay. Another reason, another place where you have to use exceptions is to indicate a failure during construction. What if you are constructing an object and the constructor fails to construct the object? There is something wrong. How will you indicate to the caller? Can you return any error code?
No.
You cannot. There you have to use exception handling. On the other hand, there are some places where you cannot use exception handling. For example, you have some code inside the DLL and you have to indicate failure of some function to the caller. You cannot throw an exception out of a DLL. I mean, you can, but you shouldn't. Why? Because the DLL might have been compiled with Intel compiler the client code has been compiled with Visual C++ compiler. And the exception handling mechanisms in different compilers is implemented differently. Understand? Okay, so exception handling between different compilers is not compatible at all. Even the overloading scheme is not compatible. If you have worked with DLLs, you see we apply extern C on functions, or we use the module definition file. Why do we do that? Because of name mangling. Name mangling is dependent on compiler. So the answer is, if you can handle the problem without exception handling elegantly, then don't use exception handling, because there is some small overhead of exception handling. In fact, I had an article about the overhead of exception handling. Yeah, I have it. I just read it recently. I'm going to paste a link in the chat. There you go.
Great, great, yeah.
So basically, you should not misuse exceptions. Don't use them everywhere. People misuse them, and then they complain their program is slow.
No, but I think the original the idea was you will write a linear code without doing error checks at many times, and that improves readability and also less overhead, right? Because under normal condition, you are not paying any price with the by just doing it whether something has error out. So that philosophy still holds, right?
Yes, and there is another thing. Even if you have exception handling code in your application, you won't really pay the price until the exception is thrown.
Exactly, yeah.
There's a very little amount of memory footprint that is required by exception handling. So with our binaries being 100 MB, 200 MB, what is a few more 100 bytes?
Yeah, exactly, yeah. And
for certain kinds of applications.
Yeah, I mean, this overhead goes on your stack, right? So every function call will have associated overhead with related to exception, right? And typically
Yes.
we saw, I mean, here internal development, we saw the height of stack is less than 500 frames, not more than that. So even if you lose like 8 bytes per thing, you are not losing more than 4 KB or something, or
Exactly.
16 KB to that.
Yes. Yeah.
Interesting. Yeah. Thank you. Article is there, na, in chat. Yeah.
I have I've sent the link
Okay,
in the chat.
Good.
So one thing I wanted to mention is the decision will be also affected by the type of platform your executable is going to execute on. If it is an embedded platform, then maybe you want to keep your memory footprint down. So there you may not use exceptions.
Yeah.
Okay, so this was about
correct. So I think there is also some industry specific standards for this. So especially basically how do you should structure your code? I mean, so I mean we have certain so for example embedded controllers, right? So their code typically looks like there would be they use error codes, and their code looks like a services, I mean microservices. There would be you will call them and each time step you will get some return value out of that. So
got it. Yeah,
a lot of standards govern how you should code be written.
Yes. See, there is a standard for the vehicle industry that is called MISRA, MISRA.
Yeah.
There is another standard for jets, airplanes. There is so there are a lot of standards. Then for general programming, we have coding guidelines. modern C++ coding guidelines. So yeah, every industry has their own guidelines. For example, if you are in this medical equipment industry, so I used to train at Medtronic. Medtronic is a well-known company that makes these, high-end medical equipment. They have their own standard.
Yeah.
So Google has their own standard, where they say don't use exceptions.
Correct. No, I mean, what amuses me that these C++ guys, they were able to come up with a library that can be used in all these standards, right? It spans across the standard. So
which
this
library?
STL library. So
okay,
essentially,
yeah.
They could satisfy everyone's need where the applications are so diverse, right?
Yes.
That is something we need to appreciate, at least here in this.
No, but sometimes they will break the ABI also. No, I think C++ updates. They will sometimes break the. I think that ABI or something.
Yes, they will. This is a big problem in C++. ABI, application binary interface. There are a lot of incompatibilities. That is why we cannot use C++ for writing low-level code, device drivers, or DLLs, unless you use some kind of protocol such as COM. But it's not used much anymore. By the way, about this STL, it was not written by C++ guys. It was written by Alexander Stepanov and Dave Musser and Atul Saini, I guess. So this guy, Alexander Stepanov, he's a mathematician, and he had implemented a library in Ada programming language because it was generic programming language. And then when C++ was invented, he was interested in C++ because of how it was. It was very close to C. It was basically there were no layers. It was close to the metal, close to the CPU. So that's why he then proposed his library to the committee members, and they suggested some changes, and it was finally ratified as part of C++ in '98. So it's an interesting history. There's this book that contains the entire history. It's very interesting. So you search for Alexander Stepanov. He's written a book, something called Generic Programming or something. It's a wonderful book. I have read some part of it, and it is really great. It's really great. Alexander Stepanov. Yeah, Alexander A. Stepanov. So he has written this book, From Mathematics to Generic Programming. You read the first chapter, you'll be amazed by how he has written the book. I'll copy this and put it in the chat, just in case you're interested in the book.
Yeah.
So this STL is actually pure maths, pure maths.
No, and the other is like other libraries also, like Boost, for example, or even Boost. Qt has their own way of doing things, but I think they are all template based and similar to what these guys do.
Yes, Qt is not wholly template based, but yes, it uses templates, and even ATL, Active Template Library, which was heavily used on Windows in the past. And it was very complicated library, very complex. So,
one like thing just I heard somewhere, like I was told that you don't pass vectors from across like DLLs if I'm calling function from another DLL. So you shouldn't use vectors. So can you explain?
Yes,
like,
you shouldn't do that. It is difficult to explain, at least today. Let me finish off vectors first, and then I'll tell you why you should not pass.
So, can you pardon with the claim? What was the claim? What you should not do?
So what he said was, if you have a vector in a DLL and you have to pass it to the client executable, you should not pass it across the DLL boundary.
I see.
You should not do that. Okay, yes, you should not. Even Microsoft documentation of Visual C++ library tells you the same thing. You should be careful about doing it. In general, if same compiler has been used for DLL and the EXE, then you can. Then there is no problem. Okay, but let me explain that tomorrow. No, it's binary incompatibility issue.
Okay.
All right. So that's it about array. This was the first sequence container. The other sequence container is vector. Let's create a new project. I don't even need to discuss vector because we already implemented it. So there is nothing to discuss in vector. In fact, the code that I had written earlier for iterators, maybe this main.cpp, this code, I can actually use it with vector. So let me add this. Vector is a dynamic array. That's it, period. Nothing more, nothing less. So let me remove the list code. We have containers, so we have this dynamic array. Let's call this vector basics. Okay, and I'm not going to change anything at all. This thing using I think this file that I was supposed to modify. Yeah. So for vector, you have to include the header file vector. Take care of this string view. File with C++17. And this dynamic array will be std vector. Okay, generate random. We need the utils header file. So let me copy this in the project directory. Set vector basics. All right, let's build. Thing works. It works with our generate random. It works with our find if. It works with our distance. It works with our move to. So any guesses what distance will do? What move to will do? Let's see move to, what it's going to do. Go inside move to, and let's see. Oh, it has gone here. See, include direct jump. It's direct jump. So you already know about vector now, so we don't need to discuss it. But there are some things, some important things. You remember how we allocated memory for our dynamic array and the list? We used operator new, and then we used placement new. Generally, all containers do not allocate memory themselves. All containers except array. Array is a static array. It doesn't do any allocation. But all containers, they have one thing in common. In fact, they have many things in common, but one common thing is that they don't allocate memory themselves. Instead, they use another class for allocation. And that class is called allocator. How does the containers use that? The allocator is the last template argument in all containers. And by default, the default argument is the std allocator, which is the standard allocator provided by the standard library. So you can see if I press comma here, you will see there is another argument, that is the allocator. And by default, it will use the standard allocator. Standard allocator. What does the allocator do? It provides some functions for allocation, that's all. It only allocates raw memory. It doesn't initialize the memory. So it has certain functions such as construct, destroy. See, it's deallocate, allocate. That's it. Why? Why is there a separate allocator? Why not? Why shouldn't vector allocate itself? The reason is when STL was being developed, we were still in 16-bit era, where we had concepts of for memory, huge memory. Do you know these concepts? We heard of these concepts? Segmented memory. So 16-bit had a limitation of accessing memory. So we had near pointers, far pointers, huge pointers. Do you remember?
Yeah.
Have you heard of things like this? This was in DOS. So that is why they wanted the container to be memory agnostic, memory model agnostic. But now the advantage here we have is that we can provide our own allocator. Maybe I don't want to use the standard allocator because that allocates memory on the standard heap. I may create my own heap and have the vector allocate from there. So I can customize the allocation. This is another form of strategy design pattern. So all containers except std array use allocators. We will not create our own allocator in this class. The standard allocator is good enough for most jobs, 99% of the jobs. Clear? Then all containers have a default constructor. Basically, all follow rule of 5. So they have a default constructor. They have a parameterized constructor. What will this parameterized constructor do? It will create a vector of 10 integers, default initialized. There is another constructor that will fill the vector with n values. So I want to fill it with 10 sevens. It's actually the other way around, I guess. Yeah, it's right. So I want to fill it with 10 sevens. So there's a constructor for that. Then there's a copy constructor. Then there is another constructor that allows you to initialize the container with the elements of another container. We did not implement that constructor. It's actually very easy. It is very easy. If I have std array and I want to initialize vector with this array, how do I do that? I will use a.begin and a.end. Give the size. The array header. There you go. How difficult do you think it is to implement this constructor?
No.
Very simple.
Yeah.
So all containers have these kinds of constructors. Right? Then all containers have pushback. Remember pushback? Then all containers have. Yes?
No, I said yes.
All containers have insert erase. Some containers may not have pushback. I said all containers have pushback. Some may not have pushback. Some have push front. Some may not have pop back. Some have pop front. Okay, but in general, all the containers are ranges. All provide their own iterators. So that is why everything that we are doing here still works with the vector. because we implemented dynamic array as a vector. Although vector is more sophisticated, it is more optimized. The dynamic array that I have implemented, if I want to make it the same level as vector, it'll probably take me a couple of months. Why? I implemented it in one day. Why cannot I use it in production code?
Because it is like it has to be extensible, all those kind of things, extensible, like reusable, that kind of thing.
We do not inherit from vector. We don't use vector in other. We don't use inheritance with vector. We don't extend from it. First of all, I have not tested it for correctness. Is it working correctly? There was a bug in my implementation. I fixed it later. I did not know that. Secondly, I have not optimized it. Vector is highly optimized. It is so optimized that there is a statement that I will make later. It is very, very optimized. Remember this, it is very optimized. Yeah. Then, so we have pushback. I want to show you pushback or emplace back. It also has emplace back. We already implemented that. So we'll just create a vector of maybe 10. And I want to show you something interesting. I want to show you the size, how the vector grows, and the capacity. Doesn't matter whether you use emplace back or pushback because we have primitive types. And the rest is not important for the time being. Let's push 20. So the vector will grow. In our case, we simply blindly doubled the vector, the dynamic array. The vector does not do that because it's a bad idea. Why it is a bad idea? Suppose you have 10,000 elements. The size is equal to capacity, and you add one more. What will happen? It will allocate 20,000. Do you need that much space? Probably no. See how it grows. See the growth. Or it is start from 0.
So actually, that invalidated iterator issue we faced earlier with our implementation, will we face it in the vector also, or is it?
Yes, yes, yes. I'll come to that. I'll come to that. Yes, we will face that. So here, it has just grown by 2, and then here it has grown by 3, and then here it has grown by 4, and then here it has grown by 5. See, so there is a small growth. So there is a balance between performance and memory footprint. Did we think about it? No.
Yeah, I think this seems to be highly tuned heuristics. I mean, someone must have run the benchmarks and tuned what's the right way of
the experts. And you know, do you know the name of the guy who maintains STL at Microsoft? His name is STL. Actually, it's the acronym of his name, but his name is Stephen T. Lavaway. He works at Microsoft, and he is the maintainer for STL there. So Stephen T. Lavaway. So you should watch his videos. He presents at CPPCon. Really wonderful speaker. Oh, you have his mail, right? stl@microsoft.com.
Yeah.
So that's it about the growth. So we have size, capacity, we have reserve, We have resize. Now you know whether we should use resize or reserve. I think you should know by now, right? I hope you remember. Everyone remembers. And then what about insertion and deletion? How do you insert and delete? How do you do that? Let's find out.
Yeah,
I don't need
one
find.
doubt, okay. I mean, so we saw the string view class, right? So it was a view of a string. And we said editing is not allowed. So, but we have, but I mean, community also has something like copy on write, right? Where if you write something, then we will replicate. So do we have anything here in STL? Copy on write?
Well, no. One
No.
interesting thing is that the std_string class that we have, it earlier implemented copy on write.
I see.
Okay, but then it was deemed to be too slow and it was not required. As memory grew, CPU became more powerful. Now they don't implement copy on write.
I see.
Okay, but Qt provides certain things. Qt provides copy on write on certain containers, certain classes, but STL doesn't provide copy and write on anything. No, I don't think so.
Yeah, because see, I mean, vector, right? We implemented vector, we had to move everything. So such moves, I mean, if they are copy on write, if you're writing something, we're even writing with a different values and so on, they can win. Otherwise, many the guys can share the same underlying memory or something, right? Yeah, okay. But I think they must have profiled and thought about it, pros and cons. So.
See, think about it. Suppose you have a vector of 10,000 elements, okay, and you pass this vector to another function by value. Let's say you pass it by value.
Yeah.
So if it implements copy on write, then it will be just a copy of the vector object, but internally two vectors will share the same buffer.
Yeah.
Right. And what if you write into the vector that is in the function? It will immediately do a copy.
Yeah.
So it will copy 10,000 elements. Now, why don't we need this in C++? Because if you do, see, if you want to, you know that you are going to modify it, then you will pass the vector by copy.
Yeah.
Right? You'll pass it by copy. It will immediately create a copy. So the price, you're not paying any, see, the price is same. In the first case, you're paying the price on copy on write. Here you are paying the price initial. Although in the first case, the copy may not happen at all, but that's a rare thing. And the other thing is in C++, if you know that you're never going to copy it, then you will pass it by constant reference.
Yeah.
Right. So we have that advantage here. But yes, in Qt, the containers implement copy on write. Basically, that creates a host of other problems.
Okay.
Actually creates a host of other problems. You know, if you want to know what those problems are, just look at the for loop of Qt and you'll know what I'm talking about. It has its own for each or for loop. Just look it up.
Nice. Okay.
Anyway, so this is our dynamic array. Let's not have too many elements. Let's have just 10. And if I want to talk about algorithms later. So if I want to, let's say, insert something or I want to erase something. Okay, I want to erase something. I want to erase the element at the 5th location. So we have used move to. You don't need to use move to. Move to is already provided in STL in the form of advance. Advance is already there. You want to see its implementation? Can you see the implementation? If it is random access iterator, then use plus equal to. If not, then use the loop. And it uses compile time if.
Yeah.
Earlier it used something else, but let's not talk about it. So you can use advance and then you can use erase. Okay, and the iterators of vector are random access iterator. So they support all the operators that a pointer supports. Now you know why. See, I used to wonder why we have to write something like this. Why we have to write this complex code. When I implemented my own iterator, I realized why. Why iterator is a nested member of vector or list. Because this way, when it is a nested member, all the iterators in all the containers will have the same name, iterator. If they are not nested members, you'll have to call them vector iterator, list iterator, deck iterator, array iterator. This is what happens in Java. In Java, iterator classes are outside. So you have list iterator. So you have iterator with different names. There are iterator classes with different names. Here we don't have.
So
Okay,
do they
so
Java
let's-
templates?
Sorry?
Java, is it template implementation in Java?
Yes,
Oh.
not template, but generic. There's something called generics, which is similar to templates, but it works differently.
Okay.
So we have erased the element. The element that we erased was 5. Okay, same way. Let's try something now. Suppose I want to erase an element based on its value, not on the position, but based on its value. Then how do I erase it? I can erase it like this. And this will work with list also. So that's why I'm using iterator. So nums.begin. By the way, Abhinav had asked on the first day why we need begin when we can use object.begin directly. Do you remember? Is Abhinav there?
Yes. I said like we can just use the name directly. I mean it is pointing to the first address, right?
Okay, name. You mean the name. We can use ARR directly. Now you know why we cannot use ARR directly. Why do we need begin?
Yeah. I mean because of the iterating.
Because of the iterators. Because for array, base address is fine, but for list, there is no base address, there is head address. For
Yes.
binary tree, there is root. That is why
Yes.
we cannot use. Yeah. Okay. So here, then we have it equal to nums dot end, then plus it. Please correct me if I'm wrong. So I want to remove an element, maybe 7. So I will write if star it equal to 7, I should call erase nums dot erase and then it. And then we will print the elements after erasure. Fine. Please go through the loop and tell me, and if you find anything wrong, please let me know. So let's run this. Crashes.
Yeah, but we are modifying the container while accessing it.
You should never modify the container when you are accessing it in a loop. In our case, if I use dynamic array here, chances are this code will work because I did not perform check for invalid iterators, but STL does. The library does in debug mode. In release mode, it may not perform any checks. If you compile this code using GCC, chances are even there, it will not give you any error because there are no checks. But Microsoft's implementation of STL uses a lot of asserts. So why is this happening? Think about it. You have erased the element at this location. That means the iterator became invalid. And then you are trying to increment it. That is wrong. What you should ideally do is, if the element has been erased, the iterator should move to the next element. So that is why erase returns the iterator to the next element. Since it already goes to the next element, there is no need to increment here. We should only increment when we are not erasing. Make sense?
Yeah.
So erase returns the iterator to the next element. Now here we are. We have removed 7. But I will reject this code. I will still reject it.
There is a find in STL as well, right? We could just do a find and then erase it. I mean, we can just find the.
I will reject that as well. We can do find, and then yes, we'll get the iterator, and then we'll call erase on it. Yes, we can do that, but I will reject that as well because there is something better, and we'll discuss that tomorrow. Okay, so be careful about this. Do not modify the container when you're iterating over it. Then in the so erasure will cause invalidation of the iterator. You remember when I showed you this? If it's still here, no. So let's get the iterator to the begin. And then let's advance to 5. And then let's print the value to our position. Now we are done with this. So we'll print the value. What is that value? 5. And then later on, I will insert an element at the first location. And then try to print position again. What do you think will happen? Will this work? The elements have been shifted, right? Now position earlier was pointing to the 5th location. It is still pointing to the 5th location, but we might have a different element there. See? The vector has been invalidated. Do you understand? This is what I said about vector invalidation. You need to get this clear. You know, this is very important. You're getting this? Okay, but what if I insert at the end? So I'll say insert begin plus 6. Now chances are the vector may not become invalidated. See, it's still there. Why? Because the iterator was pointing here. It was pointing here, and I added the element. I inserted 100 over here. It's not printing it. So let's print it over here. Let's print it over here. So I added, inserted 100. So the vector, the iterator is pointing to 5. I inserted at 6th location. That is not going to impact 5. That is why it did not become invalid. But hold on. There is still a problem. What is the problem? I will show you the same code will crash. How? If I
traverse it, maybe. If you traverse it entirely, then it will.
How many elements are there? 10. I'm inserting one more. So what I'll do is I will reserve for 10. Exactly 10 elements. Now when I run this, crash. Why has it crashed? And why did it not crash earlier? The reason being,
capacity.
The reason being, this is the size right now, 10 is the size, but the capacity is more. Capacity is maybe 13 or 14. So when you insert, since there is no need to reallocate, the 100 will be inserted in the same array, same buffer. So this iterator that you have is still valid. But when I reserve for only 10, the iterator is pointing to 5. There is no more space to insert. So this array will be moved to a new location. It will reallocate. and the iterator will continue pointing to old location. Is that clear? Did you understand? So don't get beat up over this. Just remember, whenever you use iterators of a vector, ensure that you always reinitialize them before using them. Do not store iterators for long term. Don't ever do that. That is not going to work. If you store iterator as a member of a class, before using it, initialize it. Always. So how to correct this code? Who can tell me how to correct this code? The code crashes. How to correct it? What to do?
You can reinitialize that. Begin. Okay, now.
Yes, we should again reinitialize pause. Don't say we will reserve for 11. No, that's wrong. So what I should do is I should reinitialize this. So nums dot begin plus 5. Now this will work. Clear? One thing about insert is, suppose we have to insert in a loop, just like we erased in a loop, we have to insert in a loop. Don't do that. Don't insert in a loop. It is error prone, very error prone. Why? Because if you keep on inserting in the loop, then the vector will keep on growing and you will never reach the end. You will never reach end. It will keep on inserting. So be careful about it. Don't modify container in a loop. Never ever do that. Is this clear? Then what are the things we have? We have nums dot c begin. Remember c begin. We have r begin.
Yeah.
We have begin const, non-const, and we have clear. We have clear, but there is one thing about clear. There is one function that we did not implement it in our dynamic array. Let's do this. Let's print the size and capacity here, and I will do this and return from here. So obviously size will be what, 1 lakh, and this is the capacity. Fine, nothing wrong with this. And then later on, I don't need the elements in the vector, so I will clear it. Let me clear it. Now what will be printed when I print size and capacity? Or suppose I erase some elements. I erase some elements. So I will use erase. I will specify the iterator that I want to, the element that I want to erase. But erase has another overload that takes a range. So I can say nums dot begin plus, sorry, that's the begin, nums dot end. I don't want to erase all the elements. I want to erase maybe all but the last 500 elements. Okay. What will happen to size? Obviously, size will now become 500. And what will happen to capacity?
So
Capacity remains same.
I have meeting.
Sorry? Capacity remains same. So don't you think there are only 500 elements and there is too much capacity? Suppose I know I'm not going to need this capacity, then what should we do? we should trim the excess capacity. We can do that through this function. We do not implement this, called shrink to fit. This will automatically shrink the vector. Okay? So sometimes this might be useful in case you have a very large vector and you have just removed large number of elements, then you can shrink it. Is this clear?
Yeah.
I hope you got a good idea about vector now. Now you know which functions to use for which purpose. If I hadn't implemented dynamic array, it would have taken a huge amount of effort to explain difference between resize and reserve. I hope you know what is the difference between resize and reserve. What is the difference between size and capacity? When to use reserve, when to use resize.
Yeah.
And how insert and erase work and why iterators become invalid. What are the different kinds of iterators provided? Why we have const iterator? Why we have reverse iterators? You know that. Why we have iterator traits? What is the purpose of type name keyword? Now you know them.
Yes.
So tomorrow we will cover rest of the containers. And yeah, that's about it. Any questions?
So what sort of containers are you planning to cover tomorrow?
All containers.
Nice.
It takes some time to synchronize. Right, if there are no more questions, then we'll call it a day. Bye everyone. See you tomorrow.
Thank you.
Thank you.
Thank you. Bye.
So I have one question. I mean, so I just
go
looked
ahead.
at. I mean, just a quick discussion while we are finishing up. So, I mean, I looked at this CPP reference and there is something called three-way comparison. Are you aware of that? What it is?
Yeah, that is a new feature added in C++ 20.
20. Okay.
That basically does away with implementation of the comparison and relational operators in your classes. So now instead of implementing less than, greater than, equal to, not equal to, less than equal to, greater than equal to, you just implement one operator.
I see.
That's called three-way comparison or spaceship operator because it looks like a spaceship.
So basically, these algorithms will invoke that operator instead of all the other 6 operators. If you have defined that, is it the case?
Yes. Since we are not discussing C++ 20 concepts, we have not implemented those operators. So if the algorithm is using those operators, it will internally fall back to using the old legacy operators.
Yeah.
So that's the beauty. It's backward compatible.
Correct. Okay. All right. Lot of stuff coming up. So I think these standards are every 3 years they appear to be coming, right? 11, 14, 17, 20, 20. Every 3 years.
It's getting crazy now. Even we are not able to keep track of these standards.
I mean, I just looked here, 98, then 2003. After 4 years of gap, then there is a huge gap between 3 and 11. How much? Like 8 years? Yeah.
In fact, 2003 is not a new standard. It was just some sort of technical corrigendum where they made a few bug fixes in the standard library.
I see.
So it's not a new standard. So there's 2011, which is a big standard, big change.
Yeah.
2014 was not much, very few enhancements. No, very few things were added, and there were mostly enhancements. 17 was again a big change with parallel STL, mandatory copy elision, new library types, and a few things. And then C++20 is a big change with concepts, ranges, three-way comparison, modules. We won't use header files now. We will use modules, just like how Java uses Java packages, something like that. C++20 is interesting.
So are you planning to just touch base with this parallel STL, or that's out of scope?
I will give you I will give you a demo. It's not that complex.
Yeah.
It's not very complex. I will give you a demo.
That will be great. I mean, we have these requirements, right? By default, if you can do few things in parallel, now with multi-core, like 12-core CPUs, I mean, that can be a nice thing to have.
Yes, especially you don't have to worry about creating threads yourself.
Exactly. I mean, especially all of us. I mean, why? Even experienced guys also stumble with the parallelism, right? So you have to be very careful, and so it's good to have something default. That would be nice.
Yeah, it's actually very interesting the way they have implemented, but there are some caveats. We'll see those tomorrow. Those are.
Okay, all right, great.
All right, see you. Take care. Bye.